So in this video, we are going to discuss the next three questions, that is question number 4, 5 and 6 from May June 2020 970931. So let's start. So here is question number 4. The curve with equation y is equal to e raised to the power 2x into sine x plus 3 cos x has a stationary point in the interval 0 to pi. Find the x coordinate of this point, giving your answer correct to 2 decimal places. So if there is a stationary point, we should know that we are going to make dy over dx is equal to 0, so that we'll get the value of x, because at this stationary point dy over dx is 0. So let's find out what is the dy over dx. We'll use the product rule because there is a product of two functions here. So let's find dy over dx is equal to first function as it is, e raised to the power 2x, differentiation of second function, and that is a combination of sine x and cos x. So sine x differentiation is cos x, and cos x differentiation is minus sine x, and 3 is a constant, so it would be 3 and minus sine x, so it become minus here, plus the second function as it is, that is sine x plus 3 cos x, and the differentiation of first function, that is e raised to the power 2x, and that is going to be e raised to the power 2x, and differentiation of 2x is 2. So it can be simplified as, I'll take e raised to the power 2x common. Now let's see what is left. Cos x is left from here, and here it is 2 3s are 6 cos x. So cos x plus 6 cos x is 7 cos x, and it is minus 3 sin x, and it is 2 sin x from here, so it is minus sin x. So dy over dx is this. So for a stationary point, or we can say at stationary point, so at stationary point dy over dx is 0, so e raised to the power 2x into 7 cos x minus sin x will be 0. So since this e raised to the power 2x will never be 0 here for the value from 0 to pi, so only possibility when this product will be 0 if that another term is getting 0. So it is 7 times cos x minus sin x is equal to 0, or we can see that they are sine and cos both, so we can make them as a tan. For that I'll transfer 7 cos x as it is, but I'll transfer sin x to the other side, it become plus sin x, and hence let's divide both side by cos, and we'll get 7 is equal to tan x, and hence from here we will get x value as tan inverse of 7, and that we will get from calculator. So tan inverse of 7 is 1.4288 and so on, so we can write 1.43 radian, because we require the angle 0 between 0 and pi, and we can see we got the value between the 0 and pi. So I hope it is discussed. So let's discuss the next part of it. B part is determine whether the stationary point is a maximum or a minimum point. For that purpose, first of all we require dy over dx, because in order to decide it we require the d2y over dx square. So let's write dy over dx. From the first part it was e raised to the power 2x, I can paste it here, it is this e raised to the power 2x and 7 times cos x minus sin x. So from here we can find d2y over dx square. That is again in the same way. We could have done it by the value before the point x is equal to what was the value we got it as 1.43. so we could have tried directly for this dy over dx just before that point and just after that point, and we can decide from the sign of dy over dx also. But there is another method. We can find d2y over dx square, and then we'll find at x is equal to 1.43 what is the sine of d2y over dx square. So I'll do that, and it is e raised to the power 2x and minus 7 sine x minus cos x, and then plus 2 e raised to the power 2x times 7 cos x minus sine x. And we can simplify it a little bit more. Take e raised to the power 2x common, and we'll see minus 7x minus 2x minus 9 sine x from here, minus and 14 minus 1 and 14 is minus plus 13 times cos x. So now we'll check at x is equal to 1.43, and this d2y over dx square is going to be, I'll check it from the calculator, two times 1.43 and then minus 9 sine of 1.43 plus 13 times cos of 1.43, and the answer is minus 123.743 and so on, which is of course less than 0, and hence graph this stationary point is maximum. This stationary point is, we can write the stationary point is going to be maximum. So I hope it is clear. Let's do the next question. So here's question number 5. Find the quotient and remainder when this is divided by x square plus 3. So let's divide it. X 2x cube minus x square plus 6x plus 3 and divide by x square plus 3, and we'll take the leading coefficient, leading term, it is 2x cube, it is x square, so we got 2x. We divide it, you got 2x, and then we'll multiply here, so 2x cube plus 6x. I'll write below the like terms, and then we will change the sign, minus minus, this got cancelled, this also got cancelled. We are left with minus x square plus 3. Now the leading coefficient is minus x square, here it is x square, so we got only minus 1, so we got minus x square minus 3, and hence change the sign, we got these two cancelled and these two got 6. So the quotient is 2x minus 1 and remainder is 6. I hope it is clear. Let's do the next part of this question. So in this part we need to use the answer in part A to find the exact value of this. So we know that if this we have already divided and quotient was 2x minus 1 and remainder was 6, so we can write 2x cube minus x square plus 6x plus 3 whole upon x square plus 3 can be written as 2x minus 1, that was the quotient, plus remainder over x square plus 3. So if we'll find the integration, first of all we are going to find the integration of these all, and then we'll put the limits. So then we got it as 1 2 3. So its integration will be x square, because x square by 2 and 2 will be cancelled, so x square minus 1, integration of 1 is x, plus 6, and it is x square 3, x square plus 3, 3 can be written as root 3 whole square, and that can, since then we'll get x square plus a square type, so integration is 6 over root 3 tan inverse of x over root 3. Now we'll put the limits 1 to 3, and it is 3 square 9 minus 3 plus 6 by root 3, and it is tan inverse 3 over root 3. 3 over root 3, 3 over root 3 is actually root 3 into root 3 over root 3, which can be cancelled, so tan inverse root 3. So tan inverse root 3 can be written as pi by 3 directly, so I'll write pi by 3 here, minus lower limit 1 square, that is 1, minus minus plus, and 1 minus 6 over root 3 tan inverse 1 over 3. Tan inverse 1 over 3 is pi by 6. So now what we got it as these two got cancelled, 9 minus 3 is 6, plus we'll simplify these two, 6 by root 3 common, so 6 by root 3 common, and pi by 3 minus pi by 6 is pi by 6, so it is pi by 6, and hence the last answer will be 6 plus 6 cancel, pi over root 3. That is the exact answer. We don't have to solve root 3 pi by root 3 because we require the answer as the exact value. So I hope it is clear. So let's do the next question. Here is the question number 6. The diagram shows a circle with center O and radius r, so it is also r. The tangents to the circle at the point A and B meet at T, and angle AOB is 2x radian. The shaded region is bounded by the tangent AT, BT, and the minor arc AB. So the area of this shaded region is equal to, the given thing is the area of shaded region is equal to the area of circle. So first of all we need to find these two regions and the area of circle, and since the radius is r, so area of circle is pi r square, and if we join this O with T, we'll get two congruent triangle, right angle triangle, so we need to find this AT, and we can directly write it is going to be right angle triangle, so r, and this would be r times tan this half angle, that is x. So but we'll write it, so in triangle OAT, tan of x, tan x is equal to AT upon OA. This implies AT is equal to OA tan x, that is r tan x, and hence the area of triangle OAT is equal to half into base r into height, that is r tan x. So we got area of AOBT as 2 times of this area, so 2 times of this area, it is going to be r square tan x. And now we'll find the area of this r sector with angle 2x, so area of sector AOB is going to be 1 by 2 r square theta, in this case theta is 2 times x, so these two got cancelled, so you got r square x, and hence area of shaded region is going to be area of AOBT, that is r square tan x minus the area of sector, that is r square x. So by the condition we'll get the answer in next line. Condition is the area of shaded region is equal to the area of circle, so it is pi r square is equal to r square tan x minus r square x. Since r is not 0, so we can cancel them all, and we got pi is equal to tan x minus x, and hence tan x is equal to pi plus x, and hence that is shown. So I hope it is clear. So let's do the next part. So in the B part, this equation has one root in the interval 0 to pi by 2. Verify by calculation that this root lies between 1 and 1.4. So since tan x is given as pi minus x, so we can make a function to find a root. We can make it as y is equal to, or fx is equal to let's make it as tan x minus pi plus x. So in order to prove that this root lie between 1 and 1.4, we'll prove it's like this. See, this is the x-axis and this is y-axis, and if you find 2 points at 1 and 1.4, it is like that they are having different sign. If they are having different sign, it means this will cross the x-axis in between, and hence the root lies between 1 and 1.4. So first of all, we'll find f of 1, and f of 1 means tan of 1 minus pi plus 1, and this is by calculator. Tan 1 minus pi plus 1, it is coming minus 0.584 and so on, and tan of f of 1.4, that is tan of 1.4 minus pi plus 1.4, it is going to be, let me put the values, 0.4, it is coming 4.056, and since f1 and the function is having different sign at 1 and 1.4, and hence root lies between 1 and 1.4. I hope this explanation is clear to you. Let's do the next part of it. Here is the C part of it. Using the iterative formula, we need to determine the root correct to 2 dp, and it is given that you need to write the answer till 4 decimal places for each iteration. We can see this this formula, we have this iterative formula, they have made it from the condition, that is tan x is equal to pi minus x. So let's find out, and just in the B part we have seen that root lies between 1 and 1.4, so we can take any value between this. So I'll take as x naught as 1.2, so that we can get x1 from this, and value is 0, so it becomes, and x1 is equal to tan inverse pi plus 1.2, and this will be getting from the calculator, pi plus 1.2, and it is coming 1.3444 till 4 dp we have written, and then in the same way x2 will be tan inverse of pi plus x1, and hence it would be, it is coming 1.3514. x3 is going to be tan inverse of pi plus x2, and that is coming 1.3518, and we'll check for one more, and then we can say from here only that this till 2 dp the answer is 1.35. we'll check one more time, and x4 is coming 1.3518, and it differs after this 4 dp, and hence the root correct to 2 dp is 1.35. so I hope it is clear and it was helpful. So we'll do the rest of the question in the next video. Thank you so much.